So good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss a sheet on thermal stress and strain. So let's begin with things. So here is the very first question that change in length when temperature of a length increases by delta T. So this is delta L is equals to L alpha delta T. Next one we have dimensions of alpha, which is called coefficient of linear expansion. So that is M0, L0, T0, K minus 1. Next is SI unit of alpha, it is Kelvin minus 1. Next is strain due to temperature difference. So strain is delta L by L. So from here, if you keep delta L as L alpha delta T, so the ratio will be alpha delta T. Next is graph between strain and alpha. So you can see that strain is directly proportional to alpha. So graph will be a straight line. And if we calculate the slope angle, it will be delta T. Next is we have three different cases. Angles are theta 1, theta 2, theta 3. So obviously tan theta 3 is greater than tan theta 2, which is greater than tan theta 1. That means delta T corresponding to graph 3 is greater than delta T corresponding to graph 2 is greater than delta T corresponding to graph 1. Next is if we draw graph between strain and delta T. So it is also a straight line as there is a direct proportionality relation. So tan theta will be strain by delta T, which is corresponds to alpha. Suppose there are three graphs 1, 2, 3. We can see that theta 3 greater than theta 2 greater than theta 1. So alpha 3 will be greater than alpha 2 greater than alpha 1. Now we have a rod which is clamped between residents and it is heated by delta T. The first question is thermal stress developed in the rod. So thermal stress is Young's modulus into strain, so it will be Y alpha delta T. Then next question is force on the wall. So we know that force is equal to area into stress. So stress is Y alpha delta T into A, that will be the force. Next is pressure on wall. So obviously pressure is equal to stress alpha delta T. Next is a rod has a length of 2 meter, alpha is 10 is to power minus 10 per degree centigrade, y is 2 into 10 is to power 8 Newton per meter square. Area is given. Then we need to find volume of the rod. So volume is A into L, area is 0.04, length is 2, so summing all we get 0.08 meter cube. Next is if delta T is 30 degree, find thermal strain. So thermal strain is Y alpha delta T. After substituting the values, we have 0.6. Next question is percent thermal strain. So multiply this by 100, we get 60%. Next is thermal stress, it is Y into thermal strain. So you just substitute the value of Y, we get thermal stress as 1.2 into 10 is to power 8 Newton per meter square. Then we need to find force on wall. So force is stress into area. After simplification, it comes out to be 4.8 into 10 is to power 6 Newton. Then is pressure on wall. So pressure is force by area or stress, and we have calculated that as equal to 1.2 into 10 is to power 8 Newton per meter square. Next is two rods have lengths L1, L2, Young's modulus Y1, Y2, temperature coefficient alpha 1, alpha 2. If we increase temperature by delta T, so obviously change in length of the first rod will be L1 alpha 1 delta T. Change in length of second rod will be L2 alpha 2 delta T. Conditions for which delta L1 is equal to delta L2 is L1 alpha 1 is equal to L2 alpha 2. Then we need to find equivalent thermal coefficient, which is L1 alpha 1 plus L2 alpha 2 by L1 plus L2. So this is a basic worksheet on thermal stress and strain, and I have tried my best to enclose every basic question so that you have a basic idea of the concepts and terminologies relating to thermal stress. Obviously there can be more applications to that, but right now this is the level 1 worksheet on this topic. So I have made things very simple so that you can easily grasp and can learn better and can move to the next level. In the next videos on this topic, I'll be making things more complex, and this will improve your problem solving skills. So just wait for it, and if you have any comments, just drop some comments on the YouTube videos. I'll be helping you. Thank you and have a nice day.